I would like to speak on a very separate subject, which is, of course, a very topical subject, today is generation planning. You see, whatever we are doing today, is a kind of a reaction, right? We are not actually, we hadn't planned properly to ensure that, we don't run into the risk we are having run into today. Major risk, of course, is about stability, but there are other risks also, about cost, benefit, about IRR for the uh, renewable energy power plants, backing down of renewable energy power plants, just to ensure that the existing thermal power plants are kept running at some minimum level. There is an issue about flexibility of the power plants, which are there, the thermal power plants. So I'm going to speak on basically on this aspect of planning. So I hope that if there are any issues in understanding the methodology I will be talking about, I would like to definitely take questions on that. But for the moment, I will take you through the methodology which I am suggesting, which we are suggesting. Not only I, many of our colleagues who are into generation planning are suggesting to follow for the for both Power Ministry, the CEA, and all the other policymakers in India. Now, this is a slide, which I have shown. I think many of you will know that in 2022, Germany became 100% renewable, but they also had a large capacity of lignite-fired, lignite PF-fired units, which were which could not just be backed down completely. So during the peak period, when the renewable energy sources, the solar power especially, was actually giving the maximum amount of energy, Germany, for the whole country, for meeting the demand, they had to push in 8 gigawatts of thermal power into the system. So which led to, renewables curtailment and wholesale prices going negative. So the bottleneck was not generation, it was the inability of the dispatchable plant to step back gracefully. So this is one of the very important issues I think we have to address. We have not addressed it as yet in India. We are talking about stability, we are talking about storage and all, basically we are trying to actually cure the disease by, giving medicines. But there has to be a proper understanding that we have failed in our planning. Even though by 2022 you knew that this is going to happen in India if India also follows the same steps as Germany had followed. But still, in our enthusiasm to bring in renewable energy, we have actually landed into a situation not only of stability, which has been discussed very widely across many seminars today, but this is what is the major issue now we are facing, is about, curtailment of renewables. Now, curtailment of renewables is a very, I would say, a very unfortunate kind of disease, we have landed into. As you know, most of the renewable energy power plants which we had installed, maybe in the last decade, the prices of those electricity generated from those plants were much higher than the fossil power plants. And of course, the modern renewable energy plants, the last maybe 3-4 years, when we have seen tariffs hitting below 2.3 or 2.4 rupees per kilowatt hour. So those developers who had put in all their money, banks who have put in the money for those large power plants in India, for meeting the renewable targets which the government of India had set, for us, for the Power Ministry, for the renewable energy, the policy makers, was, it led to this unfortunate situation that today these investors are actually facing tremendous amount of problem in terms of getting back the money which they had invested in. Now, this system, if you really look at the history of our power plant, our power and power market evolution, starting from 1983 to 2026, I have tried to show this in a kind of a presentation in which we are using a river. We started from vertically integrated SEB 1983. Then we went to we went through the economic liberalization, and demand shock was there because of sudden GDP increase for some time, and we didn't have enough power generation. And I remember in those days, I was still working in one of the big industries in India, and we had to actually curtail production of very vital metals. Electricity Act unbundling came in 2003. Luckily, I moved into distribution and came as the CEO in BSES Delhi, when we had to really migrate our entire organization from a typical, what do you call, the earlier era government culture to a new era where people had to recognize that we are running a business, we're not doing a service to the nation or service to the people. So naturally, each and every amount of money which we are spending had to be justified. I went through that. We have also seen that 2010 APDRP and Uday distribution reforms came. Certain amount of changes did take place, but really not much. But then came renewable targets by 2015, 175 gigawatt. Then renewable targets 175 gigawatt 2015 is something which was supposed to be impossible to really render, but we have overcome all that. And now the flexibility gap started becoming visible from 2022, especially in Europe and USA, where a lot of renewable energy was actually replacing the thermal power. Then today, I am going to talk a little bit about R&M mandate. Now, you may be wondering, where is R&M mandate? What does this have to do with stability, in the grid? But I can tell you, having been through right from generation, transmission, and distribution in my career, I still feel that it is the generation, which the generating plants, whether it is fossil fuel plants, hydro, or whether it is gas-fired or renewable energy plants, wind-driven turbines, whatever you name it, they all have actually the key role to play in this entire orchestra, which we have today in sustaining the grid, in ensuring that the power flows right to the customer. And not only the power flows to the customer, but the power flows of the proper quality, at the right frequency, right voltage, and also with full reliability, which means zero outage. Of course, it's very difficult to achieve zero outage, but still, that's what we have to target. So far, now I come to planning, and planning, we have been using what are known as open loop planning, These are some of the tools, which I think I have also used during my own career also when we did prospective planning for generation for 𝗴𝗲𝗻𝗻 company or BSES, etc., Tata Power also. But these were tools, which were only capturing a portion of your total time which a power plant has to undergo in its life, maybe 25, 30 years. So we looked at load flow studies, we looked at least cost optimization and deterministic capacity plans. These tools tell us where we want to go, but they do not tell us how the system behaves on the way there. Am I with you? I hope you are able to hear me and see also.
Yes.
Hello.
Yes. Sir. Yeah, very much.
Good. Thank you. So this is our planning tools were built for a simpler era. Really, I think I also long to go back to the earlier era when engineers were considered as engineers, and today engineers are more being considered as AI and smart grid and that kind of specialists. But I love that those simpler areas, because we could do planning, and there were never such risks, of stability, etc. We had problems, we had outages, but we could always come back, from the outages using our simpler techniques, which we learnt of, islanding, of having a what you call a spinning reserve, etc., etc. Now, in the simpler era, the India's power sector planning was designed for a world of predictable unidirectional flows. Coal moved to the plant, power moved to the consumer, and revenue moved to the utility. Demand grew steadily. Generation was dispatchable on command. Grid was a passive carrier. Very nice and peaceful time we all had. Especially if you have worked in Bombay or maybe in Jamshedpur or Ahmedabad, where power outages were very rare. But yes, there were problems elsewhere. So we needed to definitely change. So, but what are the planning methods we used at that time? The static optimization models, deterministic capacity plans, and load flow studies were calibrated for a slow-moving system with very few feedback interaction. Now, what do you mean by feedback? Now, whenever there is a action taken, the action results in an outcome. Does the outcome also have, an influence on the action taken? This is one of the very important, very important management discovery, I would say, which happened around 1971 in MIT. And there was a gentleman who was Professor Forrester, who was actually an electrical engineer and electronics engineer also, of course. He has designed computers. Now, he brought in this particular concept of feedback. Along with feedback, being a control system engineer, he also brought in the concept of delays. That means it doesn't mean that the effect is going to immediately have an action or the influence on the action taken. No, it may take a little bit of time. Now, for example, I'm giving you an example from your own personal life. If you create an enemy, you cannot forget about it. The enemy is also going to take a revenge, and that's going to be a feedback on you. I don't know, a lot of us have had this experience that we have tried to forget, oh, that gentleman is of no use to me, let us forget about him. But then it comes back to you quite strongly that gentleman also has an influence on you someday or the other, and then you repent, why did I do this? This is simple feedback. Now, today's complex reality of the modern grid, the earlier grid doesn't exist. Today's grid most simultaneously manage renewable generation, that follows the sun and the wind, they don't follow the load curve. They follow what? They follow the weather. And that's called intermittency, or, we have these terms which are now we are learning about duck curves and all that, which are being talked about everywhere. Prosumers, who were both consumer and who were also suppliers of power. They were injecting power into the system. So a new term came up as prosumers. Then, of course, storage. We used to have storage earlier, but that storage used to be in our car batteries and maybe, inverters in some places. But now we are having storage for the grid. Battery, technology has gone up so much with the, gigawatt size storage coming into the system. So that is another thing which we are now seeing. Along with storage, we are also seeing how long the storage can last, how to monitor the storage, etc., etc. Then we are having cross-regional power markets with intraday price signals. Having been, having been in the market, and also having procured power and distributed power in companies where I work, I could see a very revolutionary change after ABT was introduced in this country, which is availability-based tariff, which was another terminology which we had to learn and then live with. And we are, of course, people found that a lot of advantages did occur. Frequencies becoming steadier. The output, from the generating stations were also better, and PLFs were increasing. So everyone was quite happy till this animal called the renewable energy walked in with all its, magnanimity and glamour. Initially, it used to cost 17 rupees per unit, but lo and behold, the scientists and engineers, and the manufacturers brought down the price to such levels that the poor fossil fuel power stations had to face backing down. Then we have frequency regulation demands measures in seconds. I think all of you know that we have to, if there is a frequency variation, we have to recover that frequency variation in literally in milliseconds rather than seconds. Sorry, I'm having a bad cough. Then the frequency regulation. Following the frequency regulation, planning tool had to keep pace, but it did not keep pace with the system it is meant to govern. What I meant here is that we still continue even today to plan on windows. We plan for a 5-year window. No, 5-year window is too long now. We said, let us plan for 2-year window. No, 2-year window is also becoming too big because changes are occurring in so many places. Let us plan for one. Then finally, today we are actually planning for a quarter. Now, that is not the way planning has to be done in the power sector. This is my firm belief, and I think I have got a lot of people who believe in the same way, that we have to look for some other planning tool which can help us in this particular quagmire which we have landed into. Sorry. So, again, discussing, on what our current tools cannot provide. It cannot provide flight testing of the policy. Whenever we do any policy change, for example, we are bringing in some marketing, intervention into the power sector, say in the form of, giving power exchanges which have come and trading, etc. Giving now, of course, the renewable energy credits which we are also trying to give. We are giving efficiency credits also, which are again market tradable elements which are going in. Those things cannot be simulated properly using our existing tools. We have to look at something called longitudinal, modeling, which one has to do to really arrive at different policy scenarios. So,
excuse me, sir.
Sorry, am I crossing my limit?
Yes, sir. Yes, sir. Actually, we have to begin the discussion.
Okay. So another 2 or 3 slides, I'll finish. So we had to bring in R&M. The highest return intervention available is one of the areas where, we have to bring in flexibilization through R&M. Yesterday only, I had given a talk to some of the top power companies of the country, and also Mr. Razdan, our ex-power secretary, was there. We only talked about flexibilization. Now, so we need a living policy model, not a one-time study, which can look at, at least a span of about nearly 1 year. And the methodology which we can use perhaps is what is called systems dynamics, is something which can help you in dynamic analysis for strategy in these cases. Now, system dynamics is a tool which is, of course, way beyond a 15 or a 10-minute presentation, but I can tell you that it measures what capacity has been added, and it also predicts what kind of instability risk we are landing up into through a method of simulation. This is one of the curves which we have actually predicted from one of a model which we had made on Indian power sector. And what it shows is that with renewable penetration, there is going to be stress which has to be corrected, and the grid stability index is initially going to go to the roof. And unless you take timely action of R&M, you take timely action of in bringing in whatever technologies you are trying to bring in to ensure that your speed of response matches with the large generators and the turbines which have got such high inertia, etc., etc. Well, that is all I have to really speak on.